So let's get into today's work. So we learned about FOIL yesterday. Here's what we're going to do today. We are going to work on writing a quadratic equation from a graph. So we're just going to look at the graph and go, okay, here's the information I know. Turn it into some expressions, multiply them out, and we'll get the equation of the graph. So the first thing we want to do is just identify the zeros or roots. Zeros and roots are where it crosses the x-axis. So that's the first thing we're going to look for, is where it crosses the x-axis. Write the zeros as factors. This means you will use the opposites to write them. So if we have a root that is a comma 0, that turns into an x minus a. I know that sounds a little confusing right now, just saying it with no visual. The visual will come in the first example, so just take the time to write it down. I know this step might sound weird right now, like, wait, what are you talking about? It will make more sense in the context of what we're doing.
I just want to say, make sure y'all should write this down too. This is the principle to help you solve the problem that you will be covering like next couple of days, the next couple of weeks. So this is stuff that you should be writing down.
Yep. Then we're going to multiply the factors. That's just doing FOIL. We did that yesterday. And step 4 is real easy. We're just going to check with Desmos. So you were given a graph to start. You created a new equation, or you created the equation for it. So that you can just type the equation into Desmos and be like, does the graph I get match the graph I was given? So we're going through this in a rather systematic way. Look, guys, I know circles, they kind of sucked with being like, oh, this is what you do first, this is what you do second, but this right there. Okay. Yep. But now we're getting back into things that are, again, getting more procedural. And it's just going to be like, hey, do these steps every time and you'll get to the answer.
You got to write it down so you can understand the steps. Can't keep it in your head.
Yeah.
Make it easy for yourself.
We will have 3 examples with this. Again, once you see it in motion, these steps are going to make a lot more sense. And they're going to seem easier than they sound. You shall see some pencils writing, not an issue at all. But our end goal is to be able to look at that visual, hey, this is what the graph looks like, and create an equation based off of just what we see. You actually did that with linear equations where you would like, oh, there's my y-intercept, then count the slope, then write a y equals mx plus b form. You've done that sort of idea in the past, but now we're doing it with that quadratic curve, that U-shaped parabola. So we are going to focus just on simple ones that do go up, open upwards instead of downwards. It does get a little more complicated if it does not cross the x-axis. We're not going to worry about that. We're just going to worry about ones that do cross the x-axis. Yes. Thank you very much. We're taking our notes. I'll get your attendance fixed up. Yeah. Okay. Yeah, we're going to get into the notes right now. So you get that one. You'll get it after we do the notes today. Okay.
So I'll do it.
Yeah, you should be able to do it after the notes. Okay. So let's take a look at how to do this. So I see people already opening up some of the work for today, trying to take a look at it, be like, wait, a little confused right now what to do. That's why we're going to go over this example here. Now, great. This is another one. My board projects so lightly. I know on the notes, you had the PDF blank notes. You're able to see these points rather clearly. For me, for whatever reason, or because my projector's not the best, you can't see them the best. Give me 1 second to open this up on my screen so I can accurately see where they are. Here are my blank notes. I believe I have my zeros on this at 1 and -2. Correct. So again, you can see more accurate placement on the blank PDF, or you could hop on the Zoom and look at my shared screen. I know my projector is just not the best here. So right away, I want to identify the zeros. So this is step one. So my zeros here are -2 and +1. So all I do is see where these cross the x-axis. Those are my zeros. So identify the zeros. That is -2, 0 and 1, 0. So zeros are where it crosses the x-axis. Any questions on that first step? Just seeing where we cross? So that's finding the zeros. Now what I want to do is rewrite them as factors. So if something is a minus, I'm going to put it as an x plus. If something is a positive, I'm going to write it as an x minus. So my first zero was -2. So that turns into x plus 2. My other zero is just a +1. So that turns into x minus 1.
Everybody get what you just did?
Exactly. So what is really happening here, and this is going to get into what we're going to explore next week, is if I set this equal to 0, I could say, oh, since they're multiplied, I just need 1 to equal 0. What I'm writing in blue, don't worry about writing. This is a preview. So that I can be like, oh, x plus 2 equals 0. Subtract 2 from both sides, I get x equals -2. That's where it crosses. Again, I could do the same thing over here. Oh, x minus 1 equals 0. Add 1. X equals 1. Oh, that's where it crosses. So we're getting into this idea of solving to go from an equation now having a visual to find those zeros. But for right now, this is all we need to put down. I was just showing you why we take the opposites, because if we take the opposites and we solve it, we would get what we want. Now, set 3 says just use FOIL on this. So now, FOIL. Again, I like to be colorful on it. I like to give you all the support on there. So remember, FOIL stands for F is first. So x times x gives me x squared. Now my outers, x times -1. -1x or -x, either is correct. My inners, get 2 times x, that is just so plus 2x. And then finally, my last, -2, thank you. So now I know I have my like terms right here. So it just starts off x squared, -1 plus 2 is just going to be 1x. So plus x minus 2. Now, when I type this equation into the calculator, it should look just like this here. Fingers crossed it does. I know it's going to, because I know we did the work right. But when you do this, that's why I'm saying check with Desmos. It doesn't take very long to type that into Desmos and get that visual to compare side by side. Thank you. Still see some writing. You want to make sure you got that down. Before we go on to checking. Again, if you missed yesterday, this is just yesterday. So doing this FOIL process, that's all we did yesterday. So F stands for first, O stands for outer. So the first ones, the outer ones, the inner ones, and then the last one in each parenthesis. So just telling me what order to multiply in.
What's the last one?
L for last.
No, how you get the 2?
2 times -1. Let's take a look at this graph. All I'm going to do is type it in. So put the projector mode here, so it's just a little easier for you to see that. Where was I? X squared plus X minus 2. So this is what this shows me. Again, I get zeros at -2 and 1. And again, I look at my picture here compared to here. Hey, that's looking pretty good to me. Just flipping between those two. Hey, they match up. I did this correct. Any questions on this? Okay, we've got 2 more examples. Going to try and move a little quicker through those 2, okay? So here with this one, again, pulling up on the PDF in front of me so I can see a little better exactly where they are. Yep, that's where I thought they were. Identify my zeros. Here, this one is 3, and this one is happening at 5. So I have zeros are 3, 0, and 5, 0. Now, let's do the opposites of them. So since this one's 3, it's going to turn into X minus 3, because 3 minus 3 is 0. And over here, this is a 5, so it turns into X minus 5. Again, 5 minus 5 gives me 0. Now it's a matter of following FOIL. So again, first, outer, inner, last. That's all I'm doing here. Start with F. So first would be X times X. First thing in each parentheses. So X times X, X squared. There we go. Now, for these, you're always going to be starting out when you have X times X, it's always X squared. So a lot of times your first is going to have X squared in it. Now I go my outer. So the outer edges of it would be the X and the -5. X times -5, -5X. My inners. That's the 2 on the inside in the middle part. -3 times X, -3X, good. And then my last is the last number in each parenthesis. -3 times -5. Good, that's a +15. So again, I'm just gonna write here as a plus 15, just because I like to have my sign in there so I can see what's going on a little better. Combine our like terms, -5 and -3. Combine to give me x squared minus 8x plus 15. So again, I'm going to take a look at this, and actually we'll do it this way. I'm just going to do this, not full screen. Let me resize this better. There we go. It's going to be in almost the same place. So now this one said x squared minus 8x plus 15. So this is what I'm seeing here. Again, I got zeros at 3 and 5, just like I had identified. And now I flip here. Yeah, those graphs are looking the same, so that's looking pretty good. So see some pencils writing, but any questions on this one? So we'll look at one more. I think this one mixes some positives and negatives together again. Yep. So it looks like it's at 1 and -4. I'm just looking again at, yep, my PDF. It is easier to read. I'm sorry. These lines got so faint on the projector. So this point over here is -4. This point over here is 1. So that tells me my zeros where it crosses the x-axis is at -4, 0 and 1, 0. These are always very important points on a quadratic where it crosses the x-axis. That's one of the most interesting parts about them. As you saw, linear equations, they're just a straight line. But since these curve, I can cross the x-axis twice in the path of my curve. Two opposites. So since this is a -4, x plus 4. Since this is a +1, x minus 1. Now again, we're going to follow FOIL. F stands for first. So x times x squared. My outer is x times -1. That's just going to be -x. My inner's 4 times x. That's going to be a +4x. And then last, I have 4 times -1. That's going to be -4. Now, my outer and inner are always my like terms, so I can always combine them. So x squared, then -1 plus 4 would be a +3x minus 4. So again, what I want to do is I want to look at this visually. Oh, there's my graph. So I need to change up this equation to x squared plus 3x minus 4. Again, I can click here and here. Yep, that looks pretty good. I could even find the minimum if I want. Now, on my graph, it's a little hard to read exactly where the min is, but it does look like it should be in that area because where I flip back and forth between them, see that? See that? So my graphs look pretty similar, not perfectly on top of each other with how I have them lined up on the computer. But yeah, those graphs look to be the same. So again, that's how I can check myself. So right now we have about, what's that? About 35 minutes left in class to try this work. You will have about 8 problems to do, just like these 3 examples. The reason I cut it down from, oh, yesterday you had 18 problems to do to only 8 today, as we're seeing, this is a little more of a process. Not crazy more. It's not that much harder than what we were doing yesterday, but it's going to take you more time because you have to think a little bit more. It's not as, oh, just run through them all. So that's why I'm giving you less problems. Go ahead and get started on that. Gordon.